Okay, I want to go give a quick demonstration of HTTPS or SSL in practice. I'm going to do this with some sample code, some modified sample code that's in your Node HTTP examples directory. If you look at my terminal screen in front of me, I modified your HTTP echo program to output a simple web form that you see here. I just hard coded it right in the response stream. And on post, right, if my method is not get, then it's post, it's going to accept that information and simply echo it back. I'm listening on port 8001 and I'm running under HTTP. So what I can do if I go to that site is I can use something like a packet sniffer here to look at my network traffic. I'm going to clear this as kind of listening. I'm going to reset it. All right, so I have an empty screen. I'm going to go to my browser. I'm going to go to this website. So it's running on my local host at port 8001. All right, and I got the simple form up, and I can type in anything I want. I can type in Sue, and I get it echoed back. When I go back and look in my Wireshark, this is Wireshark, by the way, a freely available packet sniffing type tool. There's plenty of them, although Wireshark is arguably the most popular. I can see the nature of my TCP/IP traffic going through. I'm filtering port 8001 here, including seeing the output of things like my GET request. All right, and you could see down here, kind of, that things are not encoded or encrypted in any way. All right, I can actually make out the English here in my binary map that it's showing me, and I can see various parts of the message going through here that Wireshark has identified for me, right? And going back to the post, all right, and the things that are in the post, and so on, all right. So the point is I'm writing traffic free and clear, and anybody who had a packet sniffer like this out in the network and is on the same network or is a routing device through which packets are flowing could easily pick up and see what kind of traffic's going back and forth between the web server and the web client. I'm listening on the loopback, but it's all on my laptop. But again, this works arbitrarily for whatever network I might be on. Now, what if we wanted to change this? What if I wanted to create a version of the Echo program that used HTTPS? In other words, I wanted the traffic encrypted. So in the interest of time, I already have a version of this, HTTPS Echo. Sorry, having trouble saying that. Notice that I'm using a slightly different module here, my require of HTTPS instead of HTTP. I've also included the file system module so that I can read key files that are on my hard drive. Now, keep in mind here, what we're talking about, recall the slide on how certificates work and signing works. Typically, a third party is issuing their certificates, a trusted source, to both the browser and to whoever the provider is, so that the keys are trusted to be exchanged to do the encryption. Now here, we can create our own what's called self-signed certificates. Self-signed certificates means you're generating the cert file. It's not going to come from a trusted source, so your browser is going to worry about that. So I could be out at my command line window, and I'm going to cut and paste here in this directory. Now, I already have these keys, by the way, in my subdirectory. I'm going to move those aside. I'm going to move the keys over to, let's call it keys 2, and I'm going to make a different keys directory, and I'm going to go into keys directory and invoke the commands that are in the comments of that, and I'll post this code up to your repository. There's first command, generate the RSA part. Then the second part here is generate the cert request CSR file. For that, you have to fill in some information. And this is the kind of thing if you create a real cert that you would do through a certificate authority. I'm in Arizona, locality. We're in Mesa right now. I'm in Mesa right now. Organization name, ASU, organizational unit, software engineering. Common name, my name, I'll put in there. Email address, I think I'll put in that. a challenge password, I'm going to skip it. An optional company name, I'll skip it. All right. So that generated the CSR file, and now I can go over and do the last step to actually generate the certificate files. All right. Now when I look, I have these files sitting in this directory. I'm actually already running the server over here. I'm actually running both servers. I'm running the HPS Echo in the background, HP in the foreground. We've already run HP Echo, so I'm going to take this and I'm going to put this in the foreground. That's HPS Echo. Just so you believe me, I'm going to start it again. Node HPS Echo JS. So now I'm running the Echo server over SSL. That code over here is running it on port 8443. The standard port for HPS connections is 443, just like port 80 is a standard for regular HTTP. So by convention, I'm adding the 8000 to it and calling it 8443. The rest of the code, by the way, is staying, excuse me, staying the same, right? I applied these certs by putting them in the options, indicating them in the options, and the HPS call for create server takes a first parameter of those options now, as opposed to just going straight to the callback. So now I can go back to, I'm going to go clear out my Wireshark from before, my 8001. I'm going to change this filter to 8443. All right, clears it out because I wasn't listening to anything of that before. And I'm going to go over here to another browser tab and go to 8443. Now what do I get? I get one of these privacy errors, right? Because what just happened is that step where the browser got the certificate from the server, but it says, hey, the certificate authority is invalid because I'm using a self-signed certificate. Perhaps you've seen sites, I'm sure you've seen a site at some point or another, where you get a message, something like this, saying, hey, you know, this might be some fake certificate, or at least is a certificate I don't trust, so maybe you shouldn't be giving out your keys for encryption. That sometimes it's just a case that you don't have that particular signing authority loaded into your browser, and you can add it to your browser or accept it for future use. But sometimes it is because somebody's trying to give you basically a bogus certificate. We can even look at the advanced information there and see, and it tells me what host, local host, and so forth. Now we know this is a self-signed certificate, so we're going to proceed to localhost, do what's unsafe. Now I've got the same thing back, right? I'm still running my app here. I'll type in Joe. I'll hit OK. I did the post. So functionally we're exactly the same, and in my browser I can still see. Oops, I double-clicked on that. I still, I'm still able to tell what my headers are and so forth. Notice I have a new cookie here that helps me with the session-oriented logic. That's basically, if you recall back when we talked about server state, SSL is one way because the SSL essentially makes us connection-oriented. It's a dedicated channel, if you will. At least simulates it. But again, the underlying implementation, just like our session logic, is to use an underlying cookie for this SID, if you will. All right, we've got the form data and so forth, all set to go. But if I go over here and look at my packet sniffer, which I really kind of screwed, I guess I didn't have it going, so let me go hit a reload here. All right, and now I got some stuff coming through. Notice how I have all TCP stuff. It doesn't say HTTPS anywhere on it, but I can see things hitting the port and things coming back, whether it's my TCP acknowledgments or things that would have update information. Wireshark doesn't have a built-in way of looking at things. Now notice I can see things like localhost here and part of the HTTP header saying HTTP1, but I don't see the data I saw before of the rest of the payload embedded in here. And that's because it is encrypted with a self-signed certificate. So I'm able to read it in the browser, but at the network level, if I'm sitting here sniffing like this, I can see some limited header information at the TCP level, but I don't see anything else. I don't see the payload. I don't see the data going back and forth. All right, so that's just a quick demo, real quick and dirty, to see what network traffic actually looks like when you encrypt it. That gives us the encryption part, is what I showed here. The certificate part would typically be something installed on your server. Those files that we generated over here in the key directory, these files would be things that are come from a certificate signing authority. So typically, when I did this, for example, on my servers at ASU, I would generate the CSR file through a particular process with particular options dictated to me by my vendor, and then I would send those files off, and sometime later I would get back from them, hey, here's your valid certificate files that you need installed locally on your server to serve content. All right, so there's a quick demo of SSO.